Hello, my name is Oliver Korn and I head the Research and Development Department here at ECOROLL Inc. Today I would like to introduce you to the ECOsense technology and explain why it is so important for enabling a process-secure hardening process. Basically, we use the hardening process to increase the lifespan of components. This means we want to harden the material, we want to strengthen the component so that it lasts longer, performs better, and ultimately delivers better performance. We often talk about safety-critical components, where it is essential that the required compressive residual stresses and surface hardenings are present, and that we do not have fluctuations due to quality, which could lead to varying lifespans in the process or the component afterwards. The hardening process itself is very reproducible, with minimal fluctuations. We have already demonstrated this in several instances. We have also pointed out in various videos how reproducible the introduction of compressive residual stress through a hardening process is. The main parameter we need to consider is the geometry of our rolling body. We usually have that under control. We can also measure it and the corresponding rolling force. The rolling force ensures that we deform the material and introduce the required compressive residual stresses. The annoying thing is that I can't measure the compressive residual stress non-destructively afterwards. This means that in order to check if the residual stresses are correct and the process has run correctly, I have to destroy the component, and I have no way to perform a quality control and still use the component afterward. Where can errors that occur in the process come from? We can have shape deviations, meaning that due to the turning process or the machining process, we have deviations in the shape. And with mechanical rolling tools, this ensures that the spring deflection in the tool is different, leading to variations in process forces. A second error that we can encounter is incorrect tool calibration. Both the rolling tool and the cutting tool can be incorrectly calibrated. It could be an operator error, a typo during programming, or anything else. And suddenly, instead of 0.4 mm infeed and spring deflection, we only have 0.1 mm spring deflection. The rolling force is not sufficient, the surface still looks smooth rolled, and I have not introduced sufficient compressive residual stresses. We can often have shape deviations in the component due to wear, and also on the tool. When a cutting tool wears out, the resulting geometry also changes in some way, and this can also lead to us having different process forces during hard rolling. Especially when using mechanical tools, I can't really control it. I don't have a control mechanism to check whether the required rolling force has been applied or not. And this is exactly where the ECOsense technology comes into play. The ECOsense technology is essentially the digitization of our tools. We have developed a small computer, a small dial gauge that we can screw onto the tools, and then we can measure the spring deflection and directly convert it to the corresponding rolling force, which can then be sent to any external device. You can send the whole thing to a cell phone and have it read directly by the operator through an app. You can also have the entire process uploaded directly to a cloud via a machine connection, allowing access to this data from anywhere within the company. The advantage of the ECOsense technology is that it can detect every single error. This means that every single process, literally every single process they carry out, is recorded on the measuring clock and can be evaluated afterward. An automatic evaluation is already taking place. You can set limits. You can choose if you want to have a maximum force monitoring, if you want to avoid falling below a certain force threshold, or if you want to have a force profile that you want to follow through your machining process. This monitoring then immediately shows you on a report whether the process went well or poorly, and with that, they can identify the component and sort it out accordingly. With the ECOsense technology, they now have the ability to document each individual hardening process for the first time and provide their customer with proof that the required rolling force was applied as the most essential parameter for the rolling process. So, how does it all work? We have summarized everything here in a short video. We have a machining process of a component. This machining process runs just like any other machining process. I have a contour, and then our rolling tool comes in, which acts accordingly there. This tool works exactly like the usual analog tools we have, except that we can directly measure the rolling force and send it via Bluetooth to an external device. You can see here an example with an app on a tablet or even on a smartphone. As mentioned, you can also integrate the whole system directly into the control unit via a machine connection or run it on an external PC. With that, I have reached the end of this very short video. I wanted to raise awareness a bit about why the hardening process is generally very reproducible, but we really need to be careful in process management because we are working with safety critical components. If we do not process and document these components properly, it can lead to unforeseen failures. Thank you very much for your attention. If you have any further questions, please do not hesitate to reach out to me or my colleagues at ECOROLL Inc.